Sorry? Let's see if it works before you start. Yes. Cool. So I don't have the fancy kind of slides that Jan has. I've got the longest title ever with all the buzzwords in one, right? So, so I will be talking about Lambda and Azure. This is an AWS kind of meetup, so I'll be interested to see how many people here work with Azure. Google Cloud. All right, cool, not bad. 2, 3. All right, cool. So yeah, I promised to give you a demo, a little demo if it works. Hopefully Azure and kind of Google, well not Google, AWS come through. So who am I? I'm just a developer. I'm not the expert on AWS Lambda or Azure. I work with them every day, and I work in teams. So actually what I'm sharing is all the knowledge kind of I've gained with working with the guys I work with every day. So it's not all my stuff. If you like it, it's all them. If there's something weird in here, it's probably me. The little light here kind of denotes the learning. So as I go through this, I'll kind of pick these things up, right? So yeah, let's go through. So I've got 2 jobs. I'm a consultant with Equal Experts, writing enterprise software, mainly on AWS, and it is all serverless, which is great. Also, I've got a startup. Basically, we've built a platform for all the little wine merchants who stock all the best wines, but don't know how to sell these wines online. We give them a platform, almost like Just Eat, where you can actually go and source your wines and buy them, and we give you the best deal. And we actually have a platform on Azure, web services, and Google all together. And I'm going to talk about that in a bit, why. So just a quick kind of overview of this. I mean, a lot of people have heard about functions in Lambda, and there's a lot of talks about it. This is my take on it, right? So the first time I came across the idea was when, I got my first introduction to F#. Actually, I was sitting over having some beers with a friend, and F# came along, and I thought C# was pretty cool. I was doing C# at the time. And we decided to find out where could you use F#. Anyone here familiar with domain-driven design? Yeah? Cool. Excellent. So domain-driven design is all about kind of understanding your business domain, understanding the language, having one ubiquitous language, and then basically understanding that actually you can split up your whole domain, understand what your core domain is. This is your core business, right? So this is where your business makes money, right? This is actually the business logic that really counts. And then there's all these other services around this, which are basically infrastructure services, right? These things don't make you any money, right? They're there because actually you're going to be using either Azure or AWS, right? These are the things that talk to different services. And actually the core domain is part of it. And we kind of summarized that actually F# was a good idea to write your core domain in, because actually that's what you care about, and actually it's very fluent, right? But this was an idea we had at the time, and the idea was basically we could actually write a lot of the infrastructure code in C++, C#, and keep the core domain in pure, a pure language. I'm going to expand on this because I think this was my first understanding of the whole world. And if you look at this guy who wrote this book, Domain-Driven Design, Eric Evans, he says that your best developers should be working on the core domain. This is the code that differentiates you from your competitors, so put your best developers on it. But what really happens in the real world is all your best developers actually work on the infrastructure code, because they actually, they do everything, right? So there are very few developers companies actually put all the best developers in the core domain. They're trying to solve the infrastructure problems, right? And that's a reality in most companies. But this man says, put your best developers there, right? Expanding on the functional kind of style, if you look at functional programming, all you're doing is basically functions that take input and output, right? That's the function at the functional programming level. For me, I kind of think as Lambda and the whole kind of serverless world as a functional programming at the architectural level, right? So this is kind of at that level, you're doing functional programming. All you're doing is tying functions together. And I'm hoping my demo will kind of illustrate that. So to really understand serverless, I reckon you've got to go through this journey. I mean, I've done all this working for companies, building kind of infrastructure as code, patching, AMIs, building AMIs, Packer, Terraform, and it's a nightmare, right? Keeping all that infrastructure up to date, right? And then comes serverless, where you don't have to do a lot of this, right? So, what type of code rots quicker? Code that models your domain or infrastructure code? This is a question I always ask myself in terms of like, if your domain code is only going to change if your business changes, but you find that all the time you're fighting new libraries come about, it's new infrastructure has changed, new libraries, all the time you're trying to keep up to date, and the code that you're changing most of the time is the infrastructure code, and very little time you're actually doing anything with the domain code, right? So why write that code, right? So a lot of people talk about this as well in terms of, which is better. I mean, the last time I was at this, by the way, I thank you very much for coming to this talk, and thank you very much for giving me this opportunity. I think this is a great meetup. I've learned a lot from this meetup, right? And I mean, the last time I was here, I was talking about Azure, and it was like Amazon versus Azure versus Google, right? I kind of see it as a different world. I kind of see it as that, right? Why can't you use best of all, right? In terms of, I think as a customer, from a Barco point of view, I'm the worst customer these guys can have, because I kind of use all the free bits of every platform, right? And I mean, why can't you actually, talk to Google BigQuery, because there's nothing like BigQuery out there, right? Yeah, and why can't you call that from AWS Lambda, right? Why is there a boundary? So I kind of do that, and actually, your customers don't buy from you because you're on AWS, or they don't buy from you because you're in Azure. Give them the best service. Machine learning is amazing in Azure, right? And some bits are good in AWS. Why limit yourself, right? It's all in the cloud. So give the best service. So that's kind of my view of things. So here's a real problem. So I'm going to go through a demo. I'm going to talk about the differences between Lambda and Azure functions. Just an overview. I don't have much time to actually cover everything, but I'm hoping that it'll give you a good taster. So here's the real problem we have with the wine industry, right? Is that we actually talk to a lot of merchants. We have about 30 to 50 merchants on the platform right now, and they give us images for the wines. And we have a lot of problems with these because the images are quite bad. Sometimes they're the wrong wine, right? Which is really annoying. Yeah. And sometimes they don't contain a bottle of wine, right? And sometimes what happens is a merchant will give us a fantastic image, and another merchant comes in and overwrites it. We've lost it, right? So we wanted to solve this problem. So we thought, actually, let's solve it. How can we solve this problem? So there's many ways. If you look at it from kind of, and that's what the problem is. We actually want, our wine lovers to be looking at good images, and it's good for Google as well. If you want to be, on page 1. It's actually, they look at that. So we thought there's a couple of services. There's Amazon recognition. If we could actually point our wine images at this, it could tell us where they contain the bottle, right? Is it good enough? And actually, it's really cheap. You see, that's $1 for 1 million images scanned, and then $1.80 for 9 million, right? That's 10 million for $1.80. Why would I want to build a development team to build this code for me, right? Yeah, it's crazy, right? All I'm interested in is solving the business problem. So why do I need to build this, right? So let me use that, right? I'm never going to hit 1 million, $1, right? The other service, because this is not enough. All this is going to tell me that is, you've got a bottle of wine, and it might tell me what color it is. But I've got to read the labels as well on the wine. So I've got this solution from Microsoft Cognitive Services. It doesn't exist in AWS, right? A similar solution, but this thing reads labels in any kind of order, and it's actually really good. Actually, I ran it a couple of times. It tells you what language as well it is, Chinese or Spanish. It's pretty decent. And look at the price of this. It's 5,000 calls per month, $1.50. Why would I want to build a team around this, right? So I'll use this, and this is technically how it could work, right? I have my merchant uploading something via our merchant app to storage, and then something just sits there, looks at the storage. This is traditional way, right, of looking at things, and then finds out if this is a wine bottle. Is it a real wine bottle? Okay, fine. I'll pass it on. The next guy reads the label, and he says, actually, yeah, it's a wine bottle, that's this. And then I can actually publish it on the website, because actually I know it's a wine bottle, it's the right wine, because I've read the label. Actually a good quality image, actually basically put it on Backer.com. And you know, everyone's happy. So there's two parts of this. There's the merchant wine images catalog management, called it that. That's your subdomain, and that's your image publisher. I'm actually going to split the two because you know, the reading of the label is cognitive services. It's actually pretty good. Backer.com is on Azure. And I need to use a bit of Amazon, and I've got a merchant app which is in Amazon. So I picked Node as a version. Actually, that's wrong there. I'm actually using 6.10 on AWS Lambda. All slide, common language. And I'm going to show you how you can write the same kind of code on AWS and on Azure. And it's kind of portable, because if you think about writing code that's linked to the infrastructure, if you're linking to a library, right, you're tied to that library. But in the serverless world, you're not really tying to a library. When you know, it's actually, you get a message coming into your function, and you pipe a message out, right? You're not actually calling any third-party library, right? So I'm going to use the Azure Functions plugin with serverless. I'll show you how that looks like. We'll go through a serverless YAML. And I'm going to use one deployment platform, and I'm going to write my code in two different worlds. So what would the monolith approach look like? So these are some examples. So I would have an auto-scaling group with a web server, an image store in S3. Every time someone uploaded it, I would send a message out, something in the background, a worker spins up, you know, looks at Amazon recognition, cognitive services sends a message to Slack, and it forwards the message on to probably Azure, where Backer.com sits. That's a nice approach, right? The traditional microservices approach is like splitting, you know, single responsibilities. So this is what it could look like. You know, you got your web server auto-scaling group, send a message out. One guy is responsible for finding out if there's a bottle of wine or in that image. The second guy actually looks at it and goes, actually, I've read the label. And then the third one actually forwards it on, right? That's the traditional microservices approach. Before we look at serverless, I thought, yeah, well, there's also these constraints, right? You got HA, you've got to maintain log services, log shipping to agents, monitoring services. I've got to solve all these problems with these approaches, right? So, you know, security, identity server, how does someone log in, you know, licenses, database choice, infrastructure services, etc., right? It's quite a lot to solve. Before we get into the solution, I thought we'd do a quick overview of the differences of what's different, what's similar on a kind of a summary point. There's actually quite a lot different. I'm not going to dig deep. This just for the relevance of this demo. I'm just going to show you what's different between the two worlds, right? So AWS Lambda is all about functions and events, right? So when you pop something into S3, your Lambda, you can actually get your Lambda to subscribe to that event, and your Lambda gets called with that, you know, event. There's two types of events, asynchronous and synchronous. Synchronous are more like API gateway. I call, your Lambda gets called. Asynchronous is more like, you know, SNS, right? Kinesis, where basically you put something into Kinesis, and then Kinesis will call your Lambda, right, with the message or the batch. In Azure Functions, there's yet another concept. So you got functions triggers, which are like events, and then you got bindings. So in the world of Lambda, if I want to, let's say, based on something that's popped into S3, I want to save it into DynamoDB, I would actually have to include the SDK in that world, and then when I get the event, write to DynamoDB. In the Azure world, I don't have to write the DynamoDB piece. All I do is output my function, the message, and then I bind that output to table storage. So I never actually ever write any code that actually writes into table storage, or I can pipe that into Twilio, right? I can just bind it to Twilio. I can multiple bind it. I can write it into table storage and into Twilio at the same time. It's quite an interesting design. There's one function I have in a Barco which basically has 2 lines of code, right? And all it does is based on the merchant, I have to select something from table storage and return that data back. And basically, it's an HTTP binding and a table storage binding at the same time. The binding actually reads the table storage based on the HTTP, and my line of code just returns it, right? So one line of code in a function that actually returns data from a table, right? So there's that difference there, right? And there's no limit to number of bindings, okay? The other difference is Azure functions are grouped together into application or environment. So in the case of Lambda, when you deploy Lambda, it's actually just its own Lambda. That's it. It just sits on its own. It's got its own environment variables, etc., etc., etc. With Azure, you actually deploy an application with lots of functions. So in the Lambda, where the settings are per function, in Azure, the settings are per application, right? And there are two types. There's dynamic applications, where you invoke the function, and it will spin up the function, execute it, get rid of it, right? Similar to Lambda. Well, it'll freeze it. And there's the other model, which is similar to ECS tasks. It's running in the background all the time. These are for long-running jobs. So in Azure functions, you can do long-running stuff, right? Which you can't do in Lambda. It's 5 minutes, right? You could do something with step functions, right? But you can actually do long-running stuff in Azure. So how does a solution look like in serverless? We'll also look at the serverless YAML. I think that the serverless YAML between the two will actually show the differences. It's more visible. Okay, so it looks like that, right? It looks really scary. I looked at Jan's diagram, and there was, from YAML, and there's lots of functions around, right? But you got to remember that each of these orange bits is the bits that you write, right? These are the only things that you write, and they're only 5-6 lines of code, right? That's the code you write. So how does it work in the serverless world? So I need somewhere to upload the URL. So I need somewhere to send it to S3. So how do I do that in the serverless world? What I do is I talk to a service. All that service does is returns me back a URL, which is signed S3 URL, which I can upload the images to, right? And that's one way of uploading the images. Once the image is uploaded, it sits in S3. Save it in S3. This is the difference. So S3 calls my Lambda, which subscribes onto the S3 event. That event now calls Amazon recognition, finds out if it's a wine bottle. If it is, it publishes whether it's a wine bottle or not. Rather than use a database to save the results, what I use is S3 tags. I don't know if anyone's used S3 tags before, right? Basically, you can tag the S3 object now, which is kind of new, I think a couple of months ago. So I use the tags to tag that object. So I don't have a database. I just tag the object in S3 and then basically forward it on to Azure. And it's the same code in Azure. So in Azure, this is what it looks like. I talk to a function. That function does exactly what it does in S3. It goes to blob storage, returns a signed URL. I use the signed URL to upload the image to Azure. That kicks off an event, right? I don't write that. That calls my function in Azure. That function talks to Microsoft Cognitive Services, and then if it's a label, I post that to Slack, right? Simples. The code's here. You can actually download it, play around with it. We'll look at the YAML files. Let's look at the YAML, because I think before we run this demo, it's interesting to look at the two worlds, and I'm hoping you can read this. Oh no. Oh, sorry. Sorry. I just rewinded this. So can everyone read this? No, probably not. It's frozen as well. Demo nightmare. Right, let's go to the demo. Okay. And we'll come back to serverless YAML. So I have a super impressive UI skills. So I've actually created this simple demo that allows me to. It's a React application that drop your images, uploads it to S3 using the mechanism I showed you up there. I have a Slack channel here, and what I'm going to do here is I'm going to tail the logs from the label scanner, And I'm doing this on purpose in terms of like, I like to, well, let's see if that goes away. So if I upload a couple of images, I'm going to upload a wine with a background. That's going to write to S3. There it is. And after a while, it's going to talk to recognition. And recognition, actually, the tags on the bottle are alcohol. It's actually understood that it's a red wine bottle, and it's wine, which is quite impressive, actually. Right? It's actually understood from the image that that's what it is. I'm going to upload the other one, which is a Rioja. And let's see what Amazon recognition thinks that is. You'll see in the background that my Azure service is being called. It thinks the bottle. I'm going to upload a banana. What does he think it is? It's a fruit. So it kind of recognizes a banana as well, which is pretty impressive. So that, based on whether it's a bottle or a drink, it forwards it onto Azure. And I'm hoping this Lambda is going to fail, right? And the reason I'm hoping it's going to fail is because it's going to time out. And this is basically Lambda calling Azure, and the function hasn't spun up, right? It's timing out. But this is the interesting bit here, where in the traditional approach, I would have had to write a retry here to retry it. Lambda is going to automatically retry, yeah? So I'm hoping what's going to happen in a bit, that Lambda is going to wake up again, that event is going to retry up to 5 times, and my Azure function is going to wake up, because actually I haven't used it for about 2 hours, and that's going to do its job. Let's look at serverless YAML. If my editor responds. It's still frozen, thank you. Right, can everyone read a little bit? Yeah. Okay, perfect, right, sorry about this. Right, so on my left is the Azure function, serverless YAML. On my right is the AWS one. And you can see the differences as you go through. If you look at the right side, let's go through AWS Lambda. I can specify the memory and the timeouts. And I can actually specify the memory and timeouts on each Lambda, right? This is the difference, is basically I've got more control over what the Lambda uses. Whereas on the Azure side, all my settings are for the whole application. So when I deploy this, I get an application with 2 functions in it. When I deploy the one on the right, I get 3 Lambdas, right? Each with different settings. And the top part inherits it, right? The other interesting bit here is the exclude, which is on the Azure side of things. When I deploy Lambda, I'm packaging the Lambda and I push it to AWS. And what AWS will do is, get your Lambda, run it. On the Azure side of things, I don't push the package, I push the code. Azure builds the code on the machine, right, every time. That's why it takes a bit longer the first time. So it'll build your code on the machine, whatever instructions you give it, unless it's C#, it's different. Actually, it does that for C# as well, and to some extent F#. It will build it, and it'll run the function, right? So there's some differences here. And actually, there's no limits. I can run a lot of these functions for a longer time. I just have to pay more money for it. What it looks like in the Azure world is, these are my functions. That's my code here. I can actually directly upload the code to here, but serverless YAML uploads this. You can see that the settings here are per application. So everything is inherited at that level. All the functions inherit the settings. In the Lambda world, each Lambda has its own setting, right? So let's go back to Slack and see if I've got my demos worked. So in here, perfect, right? So I have 2 balls in here, which I was expecting. And what I've learned is that it's read the label, Worken Gran Reserva. It's a bottle of red wine, and the bottom one is a Rioja. So the second bit is done by Microsoft Cognitive Services. The first bit is Amazon recognition, and it cost me almost nothing, right? So back to the demo. So let's go a bit forward. Sorry about this. So what do I get for free? I'm not going to read everything on this list. You get a lot of this for free, right? You get auto-scaling, environment variables, security, API, durable storage, no MIs to manage, no complex code, right? It's simple. If the code's there, I'm hoping everyone will download this code and run it. The instructions are very simple. You just need to set up the accounts in the right way, and you can actually run this code. And you can actually see the code in the Lambdas is a couple of lines. There's not a lot of code in there, right? And you get a DDoS protection for free. So even though you're not using Amazon AWS Shield, Amazon they don't publicize this, but they do give you free DDoS protection for most of your services. It's not kind of DDoS protection kind of to the extent of AWS Shield, but they will protect your code being called. Yeah. And it doesn't break your pocket, right? It's all pay as you go. The real cost savings, this is another kind of thing you learn, is it's not when they're being executed. You actually save money from when your Lambdas are not running. And it's a different way of thinking. An example is where Jan and I worked at Just Eat. At 3 p.m., we had hundreds of servers running, waiting for that first takeaway. The first takeaway, people order when they leave work, 6 o'clock. By 3 o'clock, we had like hundreds of servers sitting there doing nothing, right? And that's cost, that's money you're paying AWS. In the case of Lambda, you only pay for when they're executed, and the cost is amazing, right? So the monolith, that is how much that would cost me on tiny instances. Traditional microservices, that's the cost, microservice cost. And serverless, that's the cost, right? And most of it is S3, right? So it's amazing. So testing, I want to talk about a bit more about kind of testing-wise, because this is different from how you would write normal code, right? In terms of like your pipeline is quite different when you come to doing Lambdas and functions. We tend to basically have a couple of rules. We always test edge to edge. It is a function with ins and outs, so we actually treat everything as a boundary. That's your boundary you need to test. We also spin everything in memory. So with serverless local, you can actually spin the whole Lambda in memory locally. You can actually provide equivalence. So you can spin up, maybe if you're using Elasticsearch, spin up Elasticsearch in memory. You can spin up, Kinesis in memory, and test a lot that way. You can also use, since it's so cheap, actually it's cheaper sometimes to use another AWS account to test your code. Because you're paying pennies, it's just easy just to spin up an account and actually test everything. And we rely on smoke tests to actually make sure things are working in the right way. We all follow GitHub flow. This is kind of standard for open source, but we follow this in the enterprise world, where basically the guys write some code, they create a pull request gets merged into master. In some teams, they actually deploy the pull request, like they do in GitHub, but we deploy master and basically run all the tests in memory, monitor. If something goes wrong, we can roll forwards, roll back. So what's interesting is as part of the delivery focused team, right, we basically have a couple of aims. And what serverless gives us, right, is a lot of this, right? Because we're writing little functions, we've got really quick deployment pipelines, we can run really a lot of inexpensive experiments, and we can actually focus on the core business problem. So as part of kind of our pipeline, we basically ensure that monitoring is our key kind of fallback as to when we deploy. We actually make sure that we can actually monitor our software, make sure it's running fine on production. We run a load through the system all the time. So while we're deploying, we actually load the system. There's traffic going through, that's called fake traffic, going through the system. As soon as something goes wrong, which alerts go off, we can actually roll back. And we actually kind of execute this kind of pipeline continuously. We use Elk for logging, and if you're on kind of multiple platforms, you can actually pipe all the logs into one Elk stack. And it also works from the point of monitoring as well. TIG stack can actually do stuff with kind of Azure monitoring and on CloudWatch. So yeah, do you need servers? Actually, for the monitoring and the logging part of it, we actually use real servers. And to be honest, Lambda doesn't solve every problem. Serverless is not for every kind of problem. You do need servers in some cases. Our main web server on Baco is a real web server, node server, and actually we need that because actually we are doing server-side rendering for SEO purposes. Yeah. So in the case of serverless, there's a lot of things you've got to think differently, right? So when you come to serverless the first time, it's easy to start off, but to stay serverless, you've got to actually practice, make sure that you think differently, you actually delay a lot of decisions, whether to use a database, try to use what you can from the serverless point of view, Lambda, services, and basically keep everything from a services usage point of view. When you really have to use servers, right, that's probably your last decision, right? And yeah, that's it. The code's available here. And if you really want to play around with the code and understand it, and you want something to go with it, you can buy some wine at baco.com. And that's it. Thank you very much.
Thank you very much, Raj. Thank you. That was brilliant. Thank you very much, Raj. I guess it recognizes if it's hot dog or not hot dog as well, which is great. Do you have any questions? Yeah.
Yeah, sure.
Nikos here, I do training and stuff like that. Does your deploy serverless YAML to Azure and AWS?
It is.
In one
it's
go?
one GitHub repo, yeah.
So you just do serverless deploy and it does everything for you?
It does everything, yeah.
And how do you find managing source control with those big YAML files? Can you split them up? And
Yeah, they are split up. So the serverless YAML is per kind of application. You can think of it like that little subdomain we spoke about. So with serverless, with Azure, you're only deploying a set of functions. And what we tend to do with the functions is we keep them kind of single responsibility within that little subdomain. So if it's wine label reading, we'll actually spin up an application for that. If it's something else, we'll spin up. So we have multiple applications with little functions. And in the same case with Lambda as well, you split up your kind of Lambdas, your serverless YAML into that little subdomain and keep that kind of service boundary in a way. But it's lots of little functions. Yeah.
We've got time for the last question. No? You sure? Good stuff. Well, thank you very much, Raj.
Thank you.